Hi, and welcome to this lesson. So by now we should have covered what perimeter is and the areas of some other shapes. So now we are going to talk about the perimeter and the area of circles. Now, the parts of a circle are very important. We need to know and identify the parts of the circle in order to work out area and perimeter. Now, at this level, we just need to know these few parts of a circle. We need to know what is circumference. And the circumference of a circle is the perimeter of the circle or the distance around the circle. Okay, so here I'm highlighting in yellow the distance around the circle or the circumference. Another important part of the circle that we need to identify is the diameter. Now, the diameter of a circle passes through the center. Alright, this red dot here is the center of my circle. And the diameter passes from one end of the circle, starting from the circumference, passing through the center and touching the other end of the circumference. There are infinite diameters in a circle. Okay, so I could draw another diameter here as long as it touches one end of the circumference, passes through the center, and touches the other end of the circumference. And the diameter is calculated as diameter is equal to 2 times the radius. Now let's look at what the radius is. The radius, I'm going to highlight that in blue, is this line. It starts at the center of the circle and touches one end of the circumference. Okay, now if it touches the other end, it becomes a diameter. So we could see that the radius, and we use the letter R to represent radius, it is half the length of the diameter. Okay, so these are the 3 parts of the circle that we need to know for now. Now let's see how we've used these formulas to find the circumference or the perimeter of a circle. So the circumference of a circle can be found by multiplying the diameter of the circle by this number, 3.14, or by this fraction, 22 divided by 7. The numbers 3.14 or 22 divided by 7 is called pi, and it is written in the mathematical formula as the Greek letter looking like this. Okay, so sometimes it's a straight line with 2 lines coming down, or you could use this curly wave line with 2 lines coming down. Okay, and all these represents pi, pi. 3.14 is just an approximate number. Okay, it is not the entire number that we should be multiplying by. 3.14, the entire number for pi is 3.141592654 and goes on and on and on. Okay, it's not a recurring number. A recurring number is like 3.3333 recurring, right? It's not one of these numbers. This number changes. So what we use in maths as our pi is just these first 3 digits. Or we use 22 divided by 7. If you're allowed to use calculators, you can punch in pi into your calculator and press the equal sign, and you would see this number. You could also divide 22 by 7, and you should also see a similar number. Now in your calculator, the 22 divided by 7 will give us 3.14285. 7.143, and it goes on and on and on. Okay, so noticing here it's a little different. So what we do is use the first three numbers. Okay, so this is different ways or different values you could use pi as. Now the question usually would tell you what to use pi as. If it doesn't, you choose which one you want to use. Now the formula to find the the circumference of a circle is this. The circumference is equal to the diameter multiplied by pi, and we said pi could either be 3.14 or 22 divided by 7. Okay, now circumference could also be 2 multiplied by the value of pi multiplied by the radius. And remember above we said that the diameter is equal to 2 times the radius. Okay, so here in this second form, the diameter is just being replaced by 2 times r. And we say circumference is equal to 2 pi r. 2 multiplied by the value of pi multiplied by the radius. So let's do some examples. Let's find the circumference of this circle. Now what did they give us here? They gave us the diameter. Alright, so our diameter, which is d, is equal to 8 centimeters. Now if we wanted to use the radius instead, we would use half of the diameter. Okay, because remember we said the radius is half of the diameter. So we have the radius r is equal to a half of 8, which is 4 centimeters. So let's use the 2 formula and let's see if we get the same answer. So on this side here, I am going to use diameter formula. So my circumference is equal to diameter times value of pi. Now they said take 3.14 as a value of pi. So my diameter is 8. I'm going to multiply that by 3.14. Okay, so you could pull out your working column, multiply that 3.14 by 8, and that will give us 25.12 centimeters. Alright, now remember to put your units in there or you could get that entire question wrong. Now let's use the other formula. Let's use the radius formula. Circumference is equal to 2 pi radius. 2 pi r. 2 multiplied by 3.14 multiplied by 4. Okay, if I look here, this 2 multiplied by this 4 is going to give me 8 multiplied by 3.14, which we worked out here to 25.12 centimeters. Alright, so you could use any one of these formulas. If the question gives you the radius r, then you could use this one. If not, you could use, if they give you diameter instead, you could use this one. Okay, so on page 2 we have some more examples and we need to find the perimeters of these shapes. Now if you notice, these shapes contain some sort of curved part, okay, a part of a circle or maybe a whole circle. Okay, so we need our knowledge of the perimeter of some other shapes plus perimeters or the circumference of these circles. Now let's look at the first one. The perimeter of this shape is this line at the bottom plus this curved part. Okay, now this line at the bottom here touches one end of the curved part, passes through the center, and touches the opposite end on the curved part. we could call this line the diameter. Okay, so they gave us the diameter of, now this is not a whole circle, this is half of a circle. Okay, or a semicircle. So the perimeter of this shape is equal to a half of the circumference, right, of this circle plus this diameter. Alright, so the first thing I want to do is identify what makes up your perimeter here. Now we know the formula to find the circumference of a whole circle. Okay, but we want half of that. So the circumference of the whole circle, they already gave us a diameter. So we could use the diameter times pi formula. Okay, plus the diameter is 14. Right, so let's substitute our values. We want a half of the diameter is 14 times, now they said to use pi as 3 and 1/7. If we change 3 and 1/7 into a mixed formula, mixed fraction, we will get 7 3s are 21 plus 1, which is 22 over 7. So they really want us to use 22 divided by 7 as our pi. Okay, and we're going to add back that 14. Now, we could do some cancelling here. 7 divided by 7 is 1. 14 divided by 7 is 2. So we're really looking at a half of 22 by 2 is 44. Alright? And then we're going to add that 14. Now 44 multiplied by a half, or a half of 44, is 22. And we're going to add that diameter 14 to give us a total of 36 centimeters. So the perimeter of this entire shape was half the circumference of a circle plus this diameter. And that's what we did here. Now part B, the perimeter of this shape is made up of this line here, this line here, this one, this little part that is labeled 1 centimeter, and this little part that is labeled 1 centimeter, plus this part of a circle here. This part of the circle, we need to find the diameter. The diameter will start from one end, pass through its center, and stop at the opposite end. Okay, now let's find this diameter here. Now, if this little piece is 1 centimeter, and this little piece on the other side is also 1 centimeter, if I were to draw dotted lines going down, this here is 1 centimeter, what is this piece between here and there? Right? That would be 9 centimeters minus 1, 2. 7 centimeters. Okay, so our diameter of that little part of the circle is 7 centimeters. Okay, so here we have to use our knowledge and some reasoning and some thinking to figure out what we need to get. Okay, so again, this is going to be a semicircle or half of a circle. So our perimeter of the shape is going to be the sum of half of a circumference plus 1 centimeter plus another 1 centimeter plus, we're going down this way now, 5 centimeters plus this 9 centimeters at the bottom plus another 5 centimeters going up here. Okay, Now let's work out this half of the circumference. Half of the diameter times pi. Again, they said to use 3 and 1/7, which we know is 22 over 7 as our pi. Plus, I'm going to work out this here. So that is 9 plus 1 is 10. Okay, and then this 5 and 5 will make a 10. So that's 20 plus 1, that's 21. Okay. So I have a half of my diameter. We calculated it to be as 7. And we are using 22 divided by 7 as our pi. So let's say 7 divided by 7 is 1. 7 divided by 7 is 1. And we're left with a half of 22. And then we're going to add 21 to that. So a half of 22 is 11 plus this 21 to give me 32 centimeters. So the perimeter of my shape here is 32 centimeters, sorry. Alright, so part C. We have here a rectangle and another half of a circle. We know it's a half of a circle because it starts from one end of the circle, passes through the center, and touches the opposite end on the circumference. So our perimeter here is made up of half of a circle and these sides here. If this side is 21 centimeters, then this dotted part here, which makes up the diameter of my circle, is also going to be 21 centimeters. This part here is going to be equal to this part here, which is 20 centimeters. Okay. So if you have to write out what the perimeter of our shape is, it is going to be, again, half the circumference plus this side 20 plus 21 plus another 20. Alright. Again, they want us to use pi as 22 divided by 7. A half of our diameter is 21. Our pi is 22 divided by 7. And we are adding, let's find the sum of this. This is 2, 4, 60 plus 1, that's 61. Okay. So I could cancel. 7 divided by 7 is 1. 21 divided by 7 is 3. 3 by 22 is 66. And then we have our half to multiply by plus the 61. Right? So a half of 66 is going to give me 33 plus 61, which is 94. Right? 94 centimeters. So the perimeter of my entire shape is 94 centimeters. Alright, so we have these two large shapes here. Pause the video and try to find the perimeter of these two shapes here. Okay, now let's look carefully at this one. This one is made up of half of a circle, a semicircle, alright, and this line and this line. So pause the video and find the perimeter of this shape, and then come back, unpause the video, and view the answer. In this question, they're telling you to use pi as 3.14, okay, and not 22 divided by 7. Okay, so hopefully you pause the video and try it yourself. So the perimeter, and your statements are very important, okay? Don't try to skip ahead by just putting your working on the side and then putting your answer. So again, the perimeter is made up of a half of a circumference plus the side that says 3 and the side that says 4. And they want us to use 3.14 as a value for pi. So let's go. A half of the diameter times pi plus this 3 plus 4. I'm going to replace it with 7. So a half of diameter is 5 multiplied by 3.14 plus 7. Okay. So you could work that out in your working column on the side. 3.14, sorry, by 5. A half of that, and then add 7. Okay, and you should get 14.85. Your units are centimeters. Now part E, pause the video and try part E. Part E is made up of this part of a circle. Okay, now is this part of the circle a diameter? This is not a half of a circle. So we have this 90-degree angle here. Okay, so if I were to split a circle like this, my 90-degree angle is formed between two radius and the circumference. Okay, it's formed here. So this is actually a quarter of the circumference. Alright, so pause the video and try this for yourself and find a quarter of the circumference and the entire shape, the perimeter of the entire shape. Okay. Okay, so hopefully you paused and you tried it. So our formula now for the entire perimeter of this shape is going to be a quarter of the circumference plus the 8 centimeters and the 8 centimeters. Okay. So a quarter of diameter. Now do we need the diameter? Which formula are we going to use here? We could use the 2 pi r, right? Because they give us the radius, right? We don't have a diameter here. We have a radius, which is the same thing as the diameter times pi, right? But we don't have a diameter. We actually have a radius here. Okay? So it would just be 2 times this, the 8. And the 2 8s here, that's 16. Alright, so a quarter of 2 multiplied by, they said to use 3.14 as your pi, and your radius is 8. Okay, so that plus 16. So let's work this out here. Let's make this a little simpler. I could say 4 into 4 is 1, 4 into 8 is 2, so I have 2 2s are 4 multiplied by 3.14 and then adding 16 to that, right? So that would be 28.56 centimeters. Okay, now if you have a decimal in the question part and it's the 2 decimal places, make sure to put your answers back to 2 decimal places. Alright, try not to round off this. Alright, so we have one of the most popular questions that teachers like to bring, and this here is an athletic track, and it consists of 2 equal semicircles joined by 100-meter streets. Alright, so 2 semicircles is going to make up what? 1 whole circle. Okay? So, what we need to find to make up the perimeter of this shape is going to be the circumference of a circle right, so one whole circumference plus this 100 meter plus this 100 meters. Okay, so these opposite sides here are equal. Plus 100. Now what else did they give us? They said that the radius of each semicircle is 35 meters. So they gave us the r. So we could use the formula with the 2 pi r. And they said to take pi as 3 1/7, which is the same as 22 divided by 7. So let's put in all the information. Our circumference is 2 pi r plus, and these 200s is going to give me 200. So 2 multiplied by 22 divided by 7 multiplied by the radius, which is 35 meters. And all that is going to be added to 200. So let's see what we can simplify here. This 7 divided by 7 is 1. This 7 divided by 35 is 5. And then we could multiply 22 by 2 is 44 multiplied by 5 plus this 200. Right, so that's 220 plus 200 is going to give me 420 centimeters. Oh, sorry, meters. Right? 420 meters. Our units were in meters. Okay, and that is going to be our perimeter of that entire track. Alright, so let's look at finding the area of a circle. So the formula to find the area of a circle is equal to pi, and we said that pi could be 3.14 or 22 divided by 7. Now they usually tell you which value to take. If not, you could use whichever one would be easier for you. And we are multiplying pi by r squared, and this is just the radius squared, right? Or the same as radius multiplied by radius. Okay, so this here is your formula that you need to learn for the area of a circle. Let's find the area of this circle with radius 4 centimeters. Now, if this is the radius, it means it's starting from the center of the circle to one end of the circumference. Okay, they said to take pi as 3 1/7, which is 22 over 7. So, let's find the area of this circle. So the area is pi multiplied by the radius squared. They said to use pi as 22 divided by 7 multiplied by my 4, which is my radius, squared. So 22 divided by 7 multiplied by 4 4s are 16. Okay, so we have here 22 multiplied by 16 divided by 7. And this is going to give me 352 divided by 7, 50.285, 50, and 2 over 7. Okay, so if you work this out manually without a calculator, you will get 50 and 2/7 remaining. If you use a calculator, you might get this answer with some more numbers behind. Okay, in this case you would take up to there. Okay, 0.28. You could even round it off to 50.29. So this could be 50.29. We want 2 digits, okay, because we know that pi usually goes up to 3.14. We take the first 2 digits after the decimal point. Now your unit is centimeters squared. Now we have to find the area of these lovely shapes here, but not the entire shape, just the area of the shaded parts. Now let's see what this shape here is made up of. It's made up of this larger circle and this smaller circle. Now, if we wanted to find the area of this shaded part, the best way is to find the area of the larger circle and subtract the area of the little circle, and you will get this area of the shaded part. Okay, this is just like if you have a cake and somebody takes a cup and sticks it into the cake and scoops out a circular part of the cake, right? We want to find the area of the remainder. So let's do that. So the area of the shaded part is equal to the area of the larger circle minus the area of the smaller circle. We said the area was pi r squared. So in the larger circle, we're going to use pi as, now they didn't say what to use pi as, so I'm going to use 22 divided by 7 multiplied by the radius of the larger circle. As you can see, the center is here, so 21 here is the radius, 21, but it's not just 21, it's 21 squared. Okay, and we could also write it as 21 multiplied by 21. Okay, so 21 over 1 multiplied by 21 over 1. This is the same thing. And that's the area of the larger circle. The area of the small circle, we're going to use 22 divided by 7 as our pi multiplied by, now the radius here is from this center to its circumference, which is 7 centimeters. And remember, it's 7 centimeters squared. Okay. Now, the reason why I wrote it like this is to be able to get rid of that denominator here quite easily. So if I say 7 divided by 7 is 1, 21 divided by 7 is 3. Alright, so I got rid of that 7 there. So now I have 22 multiplied by 3, which is 66, multiplied by 21. And then when I find that area, I'm going to subtract from it. And on this side, my 7s here could cancel, and I'm left with 22 multiplied by 7. Alright, so you could, in your working column, you would multiply your 66 by 21 and get 1386, and then you would subtract your 22 multiplied by 7, which is 154. Alright, so you should get this. Okay, and your units are centimeters squared. Now always make sure your units in your question are the same before doing any calculations. Okay, so here both our units was in centimeters, so we have centimeters squared. Now let's look at part B. Now part B, let's see what shape makes up part B. Before we cut this out, we have a rectangle, right? And we learned in the previous lesson that the area of a rectangle is the length by the width or the breadth. And we have a half of a circle here and a half of a circle there. So if we had to find the area of the shaded part, we will be finding the area of the rectangle, and we subtract the area of the circle and a whole circle, right? Because we have a half here and a half there, so it's a whole circle. So my area of my rectangle is going to be my length by my width, and from that I'm going to subtract the area of the circle, which is pi r squared. So this is 115 by 70 minus, I'm going to use 22 over 7 as my pi. You could use 3.14 if you want. Okay, they didn't specify in this question, so you could use whichever one you prefer. Now, what is my radius? If we look here, this side of the circle, this side of the rectangle makes up the diameter of my circle. So I need my radius, which is half of that. Okay, so a half of that diameter there is going to be 35. Alright, so 35 centimeters is my radius. So that's going to be 35 multiplied by 35, which is my radius squared. Right? So my 115 multiplied by 70 is going to give me 8050. Now, I could get rid of this 7 here by dividing that by 7 and this one by 7. That will be 5. So I'm left with 22 multiplied by 5 multiplied by 35. Okay. Now the area of my shaded part is this 8050 minus 3850, and that should give me now we could see that C is made up of a square and this piece on the inside here. Now the center of my square and the shape is going to be somewhere here. Now what do we have on the edges here? We have some quarter of a circle. Alright, 90-degree angle there. 90-degree angle. Alright, so this is a quarter of a circle, and this is another quarter, and a quarter. So at the end of it all, we have a full circle, right? So our area of the shaded part is going to be what? The larger shape, which is the area of the square minus the area of a circle. Right, one whole circle. 4 quarters make a whole. So the area of the square is side times side, or side squared, as we learned in the last lesson. And we're going to subtract one circle, which is pi r squared. So my side times side is 35 by 35 minus pi. I'm going to use 22 over 7 multiplied by, let's see what my radius is. Now, the 35 centimeters makes up from here to there, and this is going to make up, if you notice, it is 2 radius. Okay, 2 radii here. Alright, the plural of radius is radii. R-A-D-I-I. Right? So my radii is actually half of this 35 centimeters. And what is half of 35? That is 17.5. Right? 17.5. Now because I have a decimal here, I'm going to use pi as 3.14. Okay? It will make the calculations a little easier. So my radius is 17.5, and remember we need to square that, okay? 17.5 by 17.5. Alright, so you pull out your working column and you work this out, 35 by 35. Now all these questions are Form 2 level, so you are not allowed to use your calculators, as far as I know. You start using calculators in Form 3. So work these out manually and don't use a calculator. Right? So 3.14 by 17.5 by 17.5 is going to give me 961.625. Okay, and I'm going to subtract those two to find the area of the shaded part, and that is going to give me 263.375. and I'm going to round this off to 2 decimal places because my largest decimal place here is 2 decimal places, right? 2 decimal places. So 263 point, I'm going to round this up to 38 centimeters squared. Okay, don't forget that square. We're looking at area. Let's look at D. Now D is made up of a larger circle and a smaller circle on the inside. So a real life example of this question could be if you look at maybe your pencil, you have a larger circle on the outside and your pencil point on the points on the inside is this thing passing through. Okay, it could also be a tire or a circular swing. Both of these circles have the same center. They drew their line starting from one point in the middle here. Right, so they both have the same center. Now how do we find the area of the shaded part? Again, we could take the area of the larger circle and subtract the area of the smaller circle from it. So the area of the shaded part is equal to the area of the large circle minus the area of the small circle. Alright, so again we know the areas are pi r squared, and they both are pi r squared. Okay, now what is pi? Now I'm seeing some decimal points here. I could use 3.14, but if I look carefully I'm seeing 14 and 21, and they can be divided by 7 easily. So I'm going to use that 22 divided by 7 value. Now my radius for the larger circle is 2.1. That's 2.1 by 2.1. Okay, remember it's r squared. Now 7, the 7 is 1, and 7 into 2.1 is not 3 but 0.3. Okay, so I have 22 multiplied by 0.3 multiplied by 2.1 on this side, and for the small circle pi is 22 divided by 7 multiplied by, my radius now is 1.4 by 1.4. Okay, so I could say 7 divided by 7 is 1, 7 into 14 is not 2 but 0.2. Okay, So I am left with 22 multiplied by 0.2 multiplied by 1.4. Right? So again, we work this out. And for the area of the larger circle is going to be 13.86. The area of the smaller circle is going to be 6.16. And when we subtract, you will get 7.7 centimeters. Oh, it's not centimeters, right? It's meters squared. Okay. So 7.7 meters squared. Always check back your original question and make sure your units are correct. Alright, so we are on the last lap here. And we have two questions. Now this is a popular question they like to bring for you to find the area of such a shape, right? So we have a track and it consists of a rectangle and two semicircles shown below. Now the radius of each semicircle is 35 meters. Find the area of the entire track. So we have a rectangle. If you notice here, half of this side of the rectangle starts here, and this is R, and R is 35 meters. And if R there is 35 meters, then this line here as well is also 35 meters. Okay? So we want to find for the total area of the track. It is actually the area of this rectangle and this half a circle plus this half a circle, which is a whole circle, right? So we're gonna find the area of the rectangle, you draw a rectangle, plus the area of a circle. Okay. So let's find the area of that rectangle. Now, if here is 35, it means that here is 35 meters as well. So our total length of the width of this rectangle is 70. And we know the area of a rectangle is length times. We know the area of a rectangle is length times width. So our length here is 100. Our width is 70. And we're going to add that to the area of the circle, which is pi r squared. Now, my r is 35 meters. So I know that 35 can be divided by 7 evenly. So I'm going to use 22 over 7 as my pi, right? Which they also suggested here. 35 multiplied by 35 over 1. Okay. So 70 by 100 is 7,000. Plus, we could get rid of this 7 by cancelling. 7 5s are 35. And we are left with this 22 by 5 by 35, which is 3,850. Okay, so meters is our units and it is squared because it's an area. Alright. So we need to identify the shapes and we need to use the previous knowledge because we looked at rectangles, the area of rectangles in our previous lesson. Now we have a worded question here. Now when you have a worded question with no diagram, the first step you want to do is draw a diagram. Drawing a diagram will help you see what the situation is and let you work this out more accurately. Alright, so the largest possible circle is cut from a square sheet of paper of side 14 centimeters. What area of the paper is left? So we're looking at a square sheet of paper. So I'm going to look for a square sheet of paper here. Alright, so I'm going to drop this square. I have a square, and they said the largest possible circle. Now, the largest possible circle, it would be something that could fit inside of this square. Now, the diameter of that square is going to be one of the lengths of the square. Right, so the diameter of the circle, is going to be one of the lengths of the square. So this circle here is fitting evenly. If it's not looking even if it's not looking exactly fitting inside of this square here, you can use the imagination, right? So this is the largest possible circle. Now if I look at where my diameter is, it's going to be from one end of the circumference to the next end. And if you notice, it also makes up the same length of the square, right? It's also the entire length of the square. So our diameter is equal to the length of the side of the sheet of paper. Alright, so drawing a diagram helps. Alright, so we need the area left is going to be this shaded part here when we cut out that circle. Okay, so how can we find this pieces that left here? We find the area of the square and subtract the area of the circle from it. Okay. Right, nice. So the area left is the area of the square. I'm going to minus the area of the circle. So the area of a square, we know from our last lesson, is side times side. Our side here, they told us, is 14 centimeters. Our diameter is 14 centimeters, which means our radius is half of 14, which is 7 centimeters. Alright, and we need the radius to find the area of the circle. So pi r squared is the area of my circle. So my area of my square is going to be 14 multiplied by 14 minus, we're going to use 22 over 7 because they didn't say what to use, but I will use 22 over 7 because I am seeing that my radius here is easily divisible by 7. Okay, so 14 by 14 is going to give me 196. And my 7s here are going to cancel here and there. So I'm left with 22 multiplied by one of those 7s, which is 154. And that is going to leave me with 42 centimeters squared. Okay, and this is the area that is left after we cut out that circle. Right, and this brings us to the end of this lesson. You might have a worksheet or you might have a quiz to do after this lesson, and it's for you to practice and for you to get familiar with the types of questions that come for exam. So revise these formulas, learn these formulas, you need to know them by heart, and take a break and try the quiz, and I'll see you in the next lesson.